Okay, so I picked out some problems from that Shams book. Remember, when we're trying to solve a differential equation, our solution is not a number, it's a function. We're trying to find, for example, here we would be trying to find some function y as a function of x that makes this differential equation true. So the first thing we really got to figure out is, what are our dependent and independent variables? And typically, y will be dependent, x will be independent, but that's not always true. Sometimes x will be a function of t. Sometimes u will be a function of y. We have a lot of choices. So it's good to just be able to glance at a DE and determine who are the independent and dependent variables. So the fact that I've got y primes there tells me y is dependent. Y is going to depend on something else. And then I just look through and see, well, what other letters are there? Oh, well, the only other letter here is the x, so he must be the independent variable. In the homework, this is going to cause you a little frustration. Sometimes in the homework, you might have a DE. Maybe you'll have a DE like y prime minus 2y equals 0 that you have to solve. And they don't tell you ahead of time what your independent variable is. So you'll solve it, and this is not the solution, but let's say we got y equals e to the 2x plus c. You'll type that in, and it'll say, oh, you're using the wrong variable. And the reason is they wanted you to use t instead of x. Now, most of the problems will specify that. It will say someplace in the writing, use t as your variable. I think I fixed, maybe even I fixed all of them. You just got to be aware of that. If it sends you up a warning and says you're using the wrong letters, this is probably what you did. You used x instead of t. So make sure you always read the directions. Okay, so for these questions, they want us to find the dependent and independent variables. They also want us to find the order. The order is the highest level of derivative we're taking. So if I look through here, my highest derivative is 2. So this is a second order. Okay, now I do want to point out, you guys all made it through Calc 1. You know what y prime means. You've seen y prime. I don't like that notation, y prime. Prime notation is bad because it doesn't tell you explicitly what your variables are. A better way to write this out would be in Leibniz notation, dy dx. Or if your independent variable is t, dy dt. Or if it's r, dy dr. If we use the Leibniz notation, we can immediately see what our variables are. Problem is, when I'm writing a big long DE like this, that's a lot of writing. It's quicker to write prime. Prime is just a shortcut for the derivative of y with respect to whatever your independent variable is. In physics classes, you guys have all taken physics. Sometimes we want to specify, like right here, what our independent variable is, and being time. So anytime you see something that looks like this, y dot, that means the derivative of y with respect to time. Okay, let's look at this one. Same idea. My dependent variable here, I can tell is x because I've got y primes. Oh, sorry. Dependent is y. Independent, this is what I was saying, has to be x because the one with the prime is dependent. Whatever is left over, the other guy must be your independent. And my order is not my highest exponent I see. I'm not looking at exponents, I'm looking at derivatives. That guy right there is not an exponent. See how he's in parentheses? That means the fourth derivative. Y4 means Y1, 2, 3, 4. Fourth derivative. So this is a fourth order DE. And like that one would be really nasty. I don't even know if we could solve this. We could probably solve it using power series and get an approximate solution, but I don't know if we could even solve that one analytically. Okay, here we're just checking who are solutions to our DE. So we're not actually solving a DE yet, but we don't have those skills yet. They gave me this big list and they want me to check these one at a time and determine which ones satisfy this DE. So once we get good at this, a few weeks from now, the easy way to do this would be to actually solve the DE and then see which one of these could possibly fit into our family of solutions. But we don't have those skills yet, so we just got to try them one at a time. So A, let's try y equals a constant 2. Then my derivative, y dot, which is the derivative of y with respect to time. Derivative of a constant is 0. Now I'm just going to plug those in. Here's my y prime, here's my y. 0 minus 2 times t times y. So that was y dot. That was y. And the question is, question mark, does that equal t? And I get negative 4t equals t. That ain't true. That's like an X, like a non-check mark. No, that guy does not work. It's not a solution to that differential equation. Let's try, maybe C. So I've got y equals e to the t squared. Then my derivative, I'm going to have to chain rule that. Derivative of e to the anything is e to the same thing times the derivative up top. Now I want to plug that into the differential equation, y prime. I'm going to write that as 2t e to the t squared. That's y dot or y prime minus 2 times t times the original. And the question is, question mark, does that just equal t? That right there was y. And I don't think so. I think those just cancel out, right? We get 0 equals t. That's an ugly t there. Let me fix that. Nope. So that guy is not a solution. And we could keep trying these. One of these two works, and I don't remember which one. I think this one. But you could keep trying them one at a time, and you'll get at least one of these in this case. I think maybe this one works too. So this is how we check these. We just check them one at a time. Okay, here they've given me a solution to a DE. So I don't even have the DE in front of me. I don't even know what the differential equation was. I know that they've given me the general solution, and I'm looking to solve an initial value problem. This is an IVP. So my general solution was this guy. Y of x is some c1 e to the x plus c2 x e to the x plus x squared e to the x. And I want to find a particular solution that satisfies these two initial conditions. So I want y of 1 equals 1, y prime of 1 equals -1. So y of 1, just plug in 1 for everybody. For all the x's, remember these are x's, c1 times e to the first plus c2 times 1 times e to the first plus 1 times e to the first. And that's supposed to equal 1. Now I need y prime of x. So I'm going to have to take the derivative here. So derivative of e to the x is just e to the x. The c1 comes along for the ride. Here, I'm going to have to do product rule. So I'll have a c2 derivative of the first times the second plus leave the first alone, derivative of the second. And then here, I'm going to have to do a product rule. So derivative of the first times the second plus leave the first alone, derivative of the second. And now I can plug in my initial condition. I want y prime of 1 to equal -1. So plugging in a 1 for all the x's. I'll get here C2. I'm going to get an E plus another E. I think I get 2E there. Plugging in a 1 for all the x's here, I'm going to get a 2E plus 1 more E. So I think that's 3E, and that's supposed to equal -1. So I end up with this system of equations, EC1 plus EC2 equals 1 minus E. That's equation 1 here. And then this one will be EC1 plus 2E C2 equals -1 minus 3E. And I could solve this by substitution. I could solve it by elimination. And honestly, if it were me, that's what I would do. I would just solve both of these using substitution or elimination. However, it's perfectly fine for like homework problems, even on a test, to use my calculator to solve the system of DEs. Calculators can do that. To use some site like maybe Wolfram Alpha to solve this, perfectly fine. So let me show you how I would do that.